Unit 6.5, Deep versus Shallow Copy. So I went ahead in my Unit 6, I'm adding this unit. We were supposed to end at 6.4, but we're adding one more 6.5 just to take a look at deep and shallow copy. So I went ahead in the Unit 6 package to make this class have a main method. It's the one that I'm going to use. And wrote three methods, all static. All they're here for is to print each of the different types. So I have an array of ints, I have an array list of strings, and I have a point. So this topic was touched in Unit 2, but here we're going to expand it to include everything. So deep and shallow copy refers to everything. So here we go, a deep copy. That's when two, I could say or more. There's a two or more different variables with identical data. Two or more. For the shallow, different variables / objects sharing the same data. We're going to show three examples. So the intent here is to show how shallow copy differs to a deep copy. Okay, and I'm going to use three different things. I'm going to use an array of integers, an array list of strings, and a point, just so we could see it doesn't really apply to anything specifically, but to everything in computer science. So first up, array of integers. If you look in the example one, you'll see I made an array here and I'm printing it. So you can see this is a static call. I didn't say deep and shallow copy some object name equal new. I didn't create an instance to call print. I just used the class to call it, and that's because it's static. So the array A gets printed here. Then I made the shallow copy. Take a look at how shallow copy is made. You have this int b, this other variable, which is an integer array, and I'm assigning a to it. So that's a shallow copy. C is deep copy. Now what I'm doing here is I'm writing a loop over A, and I'm copying every single one into C. That's the integer array. Example 2. I have an array list of strings. Bed, ear, can. Just putting in three things so we could just focus on a smaller size and could see what the deep and shallow copy is giving us. And here's a shallow copy. List 2 is shallow copy of list. But the list 3 is deep copy, because what I'm doing here is I'm adding every single string in the list to list 3. So I have a copy of the list. Same is true of a point. 1, 2, shallow copy, P2, deep copy, P3. So I'm just going to run this and see what this thing gives us. Their copies, so they should all be the same. Here we go. These are all the same. I'm going to bring this up a little so we could see the whole thing. These are all the same, right? All the same, all the same. These are the three lists, the three int arrays, and the 3 points, right? All 1, 2. So now I'm going to go and make some changes just to show how the deep and shallow copy differs. But before I actually make the change, I'm going to tell you what's going to happen. So this A here, whenever I change B, I'm changing A, and vice versa. If I change A, I'm changing B. That's the concept of a shallow copy. In a deep copy, though, if I change C, it has no effect on A or B. Changing C has no effect on A or B. However, changing A or B has an effect on A and B, because it's shallowly copied, right? Shallow copy. So I'm going to make some changes. I'm going to do simple things so we could see. The first thing I'm going to do is I'm going to actually sort array C. So arrays dot sort, and I'm looking for sort, and I'm going to sort C. Okay? So what I said here is if I do something to C, it has no effect on A or B. Okay? So let me go ahead and print them again. Let me copy this and print A, and then print B and then print C. I want to see the changes as I go through. So let's run it again, paying attention at the top only. So here is A, B, and C at first, and look at A, B, and C again. A and B remain exactly the same, unchanged. C was sorted. What if I go ahead and sort not C, but sort B? See, sorry, let me undo that. That's the wrong spot. That should be sorting, so sort B. I'm in the right spot now. I'm sorting B. Let's run it. Let's see, first they were all the same, and then look what happened when I sort B. Sorted A as well. No effect on C. Let that one sink in. Let that one sink in. This is shallow copy. When one is changed, everybody is changed. Now it's two or more. I could have had another variable who's shallowly copied as well. I could have a D, and E, and F, all shallow copy. All of them would have changed. So what's the difference here? Shared data. See, this array here is being shared by A and B. So if A makes a change to it, it affects B. And if B makes a change to it, it affects A. Deep copy, not so. If you make a change to the deep copy, has no effect on those up here. No effect on the shallow one. If you make a change on the shallow, has no effect on the deep copy. So you could think of it this way. The deep copy is my own. The shallow copy is shared between two people. Consider these people, A and B, two people sharing this guy. And C, his own individual with his own set of values. Happens to be the same numbers, but there's no sharing going on. So I'm going to go ahead down to the array list. And again, we're going to do simple things. There's nothing crazy here. I'm just going to sort. Collections this time. Dot sort. And I'm going to sort list 2. And then I'm going to print all of them a second time. So I'm going to print list 1 and list 2. List 2 and list 3. So let's go ahead and do that. If I run this again, looking at the lists this time, see the first time? All of them contain the same thing. But when I sorted list 2, it sorted the first list as well. Shallow copy. No effect on list 3. I'll make another change. How about this? I'm going to say, okay, instead of just doing that, let's take list 3 and let me add the number 30 to it. Now what this will do is I add in number 30 and it's a string, so it makes no sense. I could add number 30 just as a string. So you can see this little 30 here in list 3. Let's run it. See? It affects list 3, no effect. No effect on the shallow copies. Let me go ahead and make this another addition. How about that? How about saying list 2? Now I'm going to add the number 20 as a string. If I do that and run it now, what would happen is A and B, should say A and B, but the list and the list 2 both have 20, right? Let's check this out here. We got to really focus in on this one. I added the 20 to list 2, but the affected list, the very first one, because of the shallow copy. One more. Let's do it again. One more. How about the points? Well, same thing is going to be true. Let me change P3. I'm going to set its location to 1, 6. P3. Then I'm going to go and print them. I'm going to print P2 and P3. Let's see what happens. Since I just changed the deep copy, it should have no effect on the shallow ones. And voila, that's what we have. This is them. That's the 3 of them there. 1, 2, and then here they are again. 1, 2, 1, 2, but 1, 6. Drive the point home. No pun intended. Let's drive the point home. Let's go with P2. Let's go ahead and set your location. I'm going to set the location to 3, 3. So what's going to happen? Since this is a shallow copy, it's going to change the guy at point P as well. So let's see that. See? 3, 3, still 1, 6, no effect. So we just saw 3 examples. I don't want to belabor the point, but at this point you should realize shallow copy, shared data. Shallow copy, shared data. You make a change to one of them, you've made a change to all of them. It affects everyone because the data is shared. Deep copy, not so. You make a change to the deep copy, only the deep copy is affected because it's its own data. It's really individual group. Individual group. Deep copy. 2 or more different variables / object with identical data. It's a copy, so you have the same data. Shallow copy. 2 or more different variables and objects sharing the same data. See that? Sharing the same data. So once we are sharing, if anybody makes a change, everyone feels it. Once we are not sharing and it's a deep copy, then only the change to that copy itself you can recognize. Again, 6.5, deep copy versus shallow copy. That brings us to the end. 6.5.